So when you guys, for those of you who were absent, you can find all you need to know right here on Teams. So you go to our team in the general tab. So I'm not sure if this pops up automatically for everybody. For me, it does. I go over here to general, and then this feed pops up, just like in Facebook, just like in Instagram, just like in Twitter. You've got your main feed for the day. It's all right there. And I have every single day. So here was Monday. And here was yesterday. So this is what most of you missed when you were on that field trip. So it tells you what is for home. It tells you what we did. So it says Tuesday, December 7th. Reminder, if you were on the field trip, you're still responsible for everything you missed. It says we finished the notes on page 11. I even posted them in the comments. And then your homework was pages 12 and 13. And here is a recording of yesterday's lesson. And like I said, here, if you click on that, there is page 11 of your notes. So for those of you who do not have this filled in, it's all on Teams. So you're going to need that. All right. So let's go through first this page. All right. So we got first we want Earth's crustal plate boundaries. I gave you divergent and transform. Which one's missing? Convergent. Then it says a divergent is where two plates, what do they do for divergent? Okay, so anything that means they move away from each other. So where two plates move away. So break apart works. I heard some other phrases. All as long as it means the same thing, you're good. What is formed when two plates move apart? Now, if you don't have this memorized, go to your reference table. Look at all the divergent plate boundaries. Here's one. There's one. There's a big one. All of those are what? No, go and everybody grab your reference table. They are all ridges. So every single divergent plate boundary is a ridge. And give me an example of one of them. That's what this was looking for. Name one. Mid-Indian Ridge. Is that one of them? Think it. Yep, Mid-Indian Ridge. Did you all put the same one? Southeast Indian Ridge. Mid-Atlantic Ridge. As long as you have one there, that's fine. One second. Okay. Convergent, what happens there? Come together, we're two plates. What's a transform plate boundary? Slide past each other. And what gets formed here? No, these aren't trenches. Faults. Oops, sorry. A-U-L. I think I still spell it wrong. No, I did it right. And give me an example of the most famous fault. Which one are you gonna give me? San Andreas. As long as you got that top half, that's all we're gonna do for today, just the basics. That should have been just review from the last couple of days there. You want to keep going? All right, so again, those of you who don't have page 11 copied in, make sure you go back to Teams and get that put into your notes. Today, we are going to move on with earthquakes. Oh, wait, no, we gotta go over the homework. Sorry. Let's go over the homework. So what do the arrows indicate? What does the reference table tell us the arrows are? They are motion. It does say it's relative motion. But it doesn't tell you if it's moving north, south, east, or west. It tells you which way it's moving compared to its neighbor. Look at the arrows along any of the trenches. What are the plates doing? Are they moving towards or away at trenches? Towards. Since they're moving towards each other, what kind of boundary is that? Convergent. Look at their ridges. What are they doing? They're moving away. And since they're moving away, what kind of boundary is that? Divergent. And find the San Andreas Fault. What type of boundary is that? Transform. Perfect. Then you didn't have to do 14. You didn't have to do that chart. I don't like that chart. Oh, forget the blue does anyways, but I like the way it looks. So then you had to question 15, draw the arrows at each area A, B, and C to illustrate the movement of these plates. You are not supposed to memorize this stuff. It's the same movement I'm talking about on here. I'm asking you basically to copy the arrows from here onto there. You just kind of had to be careful of where these areas were. You see, area A is right on the west coast of the United States. It's pointing to the San Andreas Fault. So those arrows are here. One up and one down. So they're sliding past each other. Area B is located right next to the Tonga Trench. So I see the top hats here. So what are the arrows? What would the arrows be doing there? Yeah, facing each other. So they're coming together there. And area B located right where it says Atlantic Ridge. At any of ridge, what are the plates doing? It doesn't say Atlantic Ridge, it says Ocean Ridge, but that should be them moving apart there. So that was question 15. Then 16 asked what type of boundary. So A is a transform. It didn't ask for area B, did it? Nope. A, B, and C. Did actually, if you did D, they should be pointing together as well. So A is transform. B is convergent. And C is a divergent. And finally, the movement at the crestal plates is most likely caused by what causes that movement? Convection currents. The whole reason we did the lava lamp. All right. Anybody have any questions on that? We'll move on to earthquakes. So we're going to be starting with earthquakes today. And I think everything on this slide here, I don't think anything is new here for you. All of this should be review. for the most part. What is an earthquake? Saw it. This. Earthquakes, guys, you can't, unfortunately, as much as I know, you know what you're talking about. You have to be able to put your charades into work. So this, which several of you just did, isn't an answer. I need words. This is shaking. An earthquake is the shaking of Earth's crust caused by the release of energy. So this goes on the top of the next page. What causes these plates to shake? The convection currents causes the plates to move, and then, yes, the plates, so it's interactions between the plates when they pull apart, when they bump together, and when they slide past each other. All causes some shaking of the earth. What's some damages that are going to be done because of earthquakes? Property damage, buildings, bridges, they're going to break. Houses, they could break. What are some other things though? So maybe some less obvious things. What can happen when all this stuff breaks? What are some other things that can happen? Oh, and the earth can crack. That is legit a thing. The earth can crack. What else? What else is breaking? So we got houses and bridges. Roads. Sidewalks. What else? Schools. Okay. Yeah, the grass. The earth, we're gonna sit down. I'm missing something. You're missing the whole concept.
Trees get fall down.
They can. What? The plates, yeah. What else is in the ground, maybe, or even above ground?
Think non-nature.
Oh, thanks. Maybe we need some different hits.
Bodies.
That's true. Huh? I still didn't.
People die.
Well, people will, but. All right, how about this? Well, it's true. What? Yeah, we already said it. We'll get a crack in the earth. But there's other things in the earth like pipes.
Water.
Pipes are in the earth.
Oh, no,
Mix.
Then all the water comes out. And then what?
no, God.
Okay, well, I don't, it's pretty dramatic.
Makes sense. Like,
We have the pipes underground that are bringing us water. Those drain.
pipes.
So then when I go to get a drink after this earthquake because I'm super thirsty, hey, now I can't get a drink because there's no water coming out of the faucet. So then I go to the creek and I'm like, I'll just drink out of the creek because I'm desperate. And then I'm dead.
Or go to the store.
Well, but the store, okay, the store has also fallen down. I can't get into the store. Or it's a couple weeks later and the store's out of their water anyway. So now I'm thirsty, so I go to the creek and I'm desperate. What's wrong with the creek? Oh, okay, it's frozen. Now we're really screwed. It's polluted. What did it get polluted by? Well, it could be polluted to begin with, but could it get worse during an earthquake? The gas pipe, so then it could have gas in it. What other kind of pipes are? Oh, hang on. What? About oil pipes, gas pipes? How about sewer pipes? Hang on, how about sewer pipes? Yeah, so now those sewer pipes are broken, or, oh, around here you guys got, near my house, we got those cow pool things. We do, yeah, I live in Eden, we got lots of cows there too. Not quite as many and as big a farms as they have like in Wyoming County, but we got some cow farms. So we got those pools filled with cow poop. How secure you think those are during an earthquake? During an earthquake?
It's all organic anyway.
Yeah, but I'm thirsty. I'm thirsty. That leak flowed downhill right next to the creek. Ew.
It's organic.
It is organic, but
Well, all you people say it's organic.
no, it's organic, but it's definitely gonna give me diarrhea if I drink it.
All it is silage.
Again, you're right. I agree with that statement, but if I drink it, I am still getting diarrhea. But, and I'm already thirsty, so now I have diarrhea and I'm thirsty.
Well, then drink more.
So I think you see where I'm getting here.
Boil water.
Boil the water, but oh wait, so I said something about the electricity and the gas pipes already being gone.
Then you boil it with wood.
Well, boil it with wood, okay, you're right. So it sounds like a lot of work though. And like, what if I lived in the city and not talking about cow poop, but my sewer pipe next to my water pipe?
You burn down the town.
That's why you don't live in the city.
All right, moving on then, I guess. Buildings, bridges collapse. We could have fires. We didn't mention that. What? Yeah. Is doing what? Oh, must be this guy. How can we have fires because of an earthquake? It's short, yeah, so I think that you get sparks, right? Is that what you mean by shorts out? Telephone wires fall down, they short out, they sparks. Next to that gas pipe that also broke, boom, we got nastiness, big fire, all sorts of bad things that could happen because of an earthquake. Yeah, that would be nice, right? You're right. If you were in an airplane flying above the earth during an earthquake, you would be safe. I said if you were in the air. Yeah, the good news is one.
Why is this spread?
So yeah, let's talk about that. So we already talked about a little bit of spreading disease. So we talked about if your water supply that you end up drinking out of gets contaminated, that's one way. Another thing is, so where's everybody gonna live if all their houses fall down? In the tents, in the rubble, in an area that doesn't have clean water to begin with, and with other people. Okay, so you have a whole lot of what ifs, okay? Of all those people. What? Huh? They do, yeah. There's like earthquakes every single day. We talked, man, it's a good thing you watched yesterday's lesson. We talked all about that yesterday. So when you watch the video, you can learn about that. So the key is after an earthquake, there's no houses left. So people live in tents with other people living close. So yeah, if one person had COVID, then the whole tent community is going to get one. They also don't have a lot of clean water or a nice place to go to the bathroom. So lots of diseases can be spread that way. All right, 2 vocab words you need to know: focus and epicenter. All right, so did everybody get these two vocab words? So the focus, again, this is where the actual earthquake happens. It's underground. It's where the two plates break or bump into each other. And the epicenter is located directly above that. It basically just gives a name to the place that broke. So it's a place on a map so that you can point. The next thing is most earthquakes and volcanoes happen at or near plate boundaries. We don't have many earthquakes around us because we are in the middle of a plate. We are not on a boundary. Tornadoes and earthquakes are different. But why do we?
On
Because,
hilly ground.
well, it has to do with just with what the weather system is that's coming through. We don't also get many of them because we don't have quite the right weather for it to happen too often, but we do have them, yeah. All right, the next thing we're going to do is I'd like you to gently turn the page and gently rip out page 17. We're going, so no, not this page. You're ripping out 17, the one with the reading. What we're going to do is we're going to use this reading to fill in this chart. We're going to be talking about some details about earthquake waves. We're going to be talking about P and S waves. P and S waves. It's like I paid him to ask me that because the whole next reading is all about P and S waves. What I want you to do is we're going to be looking for these 10 answers in the reading. I would like you to highlight or underline the answers as we're going along in the reading. You really don't have a choice. Well, first of all, I did say highlight or underline, and if you want a highlighter, we are passing them out now.
I know.
So for each of them, you're going to be looking for their name, their speed. So do they go fast or slow? No, you're going to listen in the reading, and you're going to underline it as you go. You're going to describe the motion. So how does it move? Also in the
All
reading.
over the place.
Not where, it says how. And then you're going to talk about the type of matter that they can travel through. When I say type of matter, I'm talking about solids, liquids, or gases. And we're going to do this by doing the reading on page 17. So that's where you're going to be reading is page 17. It looks like Mr. D is all set to read this. I just volunteered him totally. So Mr. D is going to read it. If you follow along and look for, again, the name, how fast they go, and how they move, and what they can move through. You can highlight as he's reading.
An earthquake is a natural rapid shaking of the lithosphere caused by the release of energy stored in rocks. Most earthquakes are caused by the movement along faults or faulting. During earthquake, the potential energy stored in the rocks is given off as seismic waves of earthquake waves. Although earthquakes produce several different types of waves, we will focus on two, P waves and S waves. Both waves are produced at the moment the earthquake occurs. They have several different characteristics. It's important to understand the differences between these two. Like P waves are primary waves. They travel as a region of compression. P waves are the fastest kind of seismic wave and arrive the seismic station first. Longitudinal P wave is the ability to move through solid rock and fluid rock, like water or the semi-liquid layers of the earth. It pushes and pulls the rock it moves through, the same way sound waves push and pull the air. Have you ever heard a big clap of thunder and heard the windows rattle at the same time? The windows rattle because sound waves push and pull on the glass, much like P waves push and pull on the rock. Sometimes animals can feel the P waves of an earthquake, but usually humans only feel a bump of these waves. Go ahead and highlight the items we're looking for. Quickly read about S waves. S waves, or secondary waves, travel like vibrations in a ball of jello. S waves are the second wave you feel in earthquake. The S wave is slower than a P wave and only moves through solid rock. It arrives at a seismic station second. This wave moves rock up and down or side to side.
All right, let's take a minute or so to just, again, we're just highlighting right now. You don't need to be writing yet. We can do the writing together. If you did already do the writing, it's not a big deal. So you're just, again, making sure you have this stuff highlighted or underlined. All right, what do you think? What was the name of the P wave? Yeah, hey, Cole, Brad, what's the name of a P wave?
Isn't the wave called the primary wave?
It is called the primary wave.
Try to catch it up.
I didn't try to catch you off guard because Cynthia literally said it 5 seconds before you did.
Oh, she did.
She did. Cole, how fast do they go?
They're the fastest kind of waves.
They are the fastest. They go fast. So one thing, I didn't ask you to do this, but when do they arrive at the seismic station? First. So they arrive first. What did they say the motion was here? Push and pull. And what they mean by this push and pull, I just kind of want to show you. I don't have the best way to demonstrate this, but it's similar to the way a slinky might work. So when I push and pull the slinky, you can see the different springs coming together and pulling apart as I move this. So when I push it, and this is such, I'm pretty good at that. What happens is this push and pull will happen throughout the slinky. So you can see, whoa. The best I can do.
Oh, and you want to?
I know. So how would you draw this? I basically drew a slinky and I had some of them squished together while the other ones were spread apart. And what type of matter did that P wave go through?
Water.
Solid and liquid. And by the way, when they say liquid, I am not necessarily talking about water.
Why not orange juice?
I am talking about molten rock. So rock that is liquid, melted rock.
So, lava.
So lava, yeah. How about S waves? Would you get as the name of the S waves?
Secondary.
Secondary.
Slow.
And how do they move, Hayden?
Slow.
Slow, because they move slow. When do they arrive? Arrive second, which is last.
Up and down the same side.
According to their reading, they move up and down or side to side. The picture of this wave is this. And what do they move through?
The picture
Solid.
shows.
Only solid. Feel like the S waves are super easy to remember because everything about them starts with an S. Even the picture to me just looks like a sideways S. And solids. The end for today.
Yeah. Holy moly.
Yeah, homework?
What?
No, no homework.
So,